All right. Welcome, everyone, to our next Git workshop in our workshop series on Git, presented by myself, Peter. We also got Mark and Regina and Abe, who have helped set up this workshop. And we got a lot to talk about today that build on what we talked previously. So we assume you know the basics about Git, like adding, committing, pushing, pulling, but we will recover some of these topics a little bit throughout the presentation. It's presented jointly with CodeRIT and the iSchool. We don't have the iSchool logo on here yet, sorry. Um, so let's get into it. If I can click on the right screen. So we got kind of four main sections to go through today. We're going to start off by recapping some of the basics of Git, like adding, committing, that kind of stuff, but not in too much detail. Then we're going to talk at length about branching and merging. We briefly talked about branches last time, but they're an extremely, extremely important concept in Git, and they're also one of the most confusing concepts in Git because it's how you can get lost. Next, we'll go over some useful Git commands, things like stashing and blaming and diffing that we like to use that aren't necessary for using Git, but are very, very helpful. And then finally, we'll talk about best practices and leave with some parting resources, like some useful talks on Git and other websites for reference. We'll also cover a little bit about things like undoing mistakes and a touch on collaborative Git, because that's the whole point of Git. So let's begin with a recap of the basics. So we talked about some various commits last time, and these are most of them. We talked about git init, which initializes a repository. We talked about git status, which gives you the status of the working tree. Excuse me. We can add files to the staging area, this thing called the staging area. It's like where you put the files before you put them into a commit. We create commits from the staging area using the git commit command, and then we could push and pull from a repository that's somewhere like on GitHub or GitLab or some remote location. But this kind of left us with a bunch of questions, right? It's like, how do I undo commits, right? Isn't that one of the things we talked about when we talked about a version control system or VCS? Like, that's kind of the whole point, is we are able to undo things and go back. How do we merge branches, right? If we had these two parallel universes of commits, how do we actually merge them together and work on them in the future? And how do I update my branch? Like, if we have other changes we want to pull in, how do we do that? And that brings us actually to a much deeper question, which is, what are branches really? So let's go into branches. So I started off the previous presentation, and somewhere down the line, I mentioned that branches just represent a linear sequence of commits. And this is in fact a lie already. And this diagram is also a lie, because commits don't contain a pointer to the next commit in the sequence. Very, very confusingly, commits actually contain a pointer to the previous commit. And so if you're not familiar, a pointer is just like a reference. It's saying like, hey, if you ask me where the previous thing is, I can get it to you. It's right over here. And so I know this diagram might be a little bit confusing and annoying to read, but this always reads from left to right. So commit 1, then commit 2, then commit 3. You might say, Peter, why don't you just leave the arrows pointing right and throw the technicality under the table? Well, number one, we wanted to show you how Git works. And number two, this will become very useful once we start talking about merging multiple branches. So we'll just kind of keep that in the back of your head. So we have this thing called a branch. And a branch is just a pointer to a commit. And this kind of seems a little too simple to be true, right? But it is. It's literally all it is. A branch, it just points to commit 3. And the history of this branch, like all the previous commits, you figure out just by going backwards, right? You follow these pointers back along the history. So branch 1 consists of the history of commit 1, commit 2, and commit 3. Now, we also talked about something about checking out a branch and like being on a branch, with this concept of being on a branch to make changes. And this is represented via something called the head pointer. So all it is, it's just another pointer that points to whatever current branch you're on. Now, I will mention, yes, it is technically possible to detach the head pointer and have it point to a specific commit, but that's what we call an advanced tactic or a pro move, and we try not to do that. So we actually saw a little bit about this before. If you think back to our git log, or if you can't remember it, like I can't, I just put it right here in the slide, we actually see that when we do git log and we view the history of the commit, the latest commit has this thing about head pointing to master, or in this case, head pointing to the branch. So the concept of a head pointer comes up all the time in Git, and it just references where you currently are. So don't get too confused by what the head pointer is. It's just where you are. Yeah, head is a pointer to our current branch. All right. So let's say we actually go in here and we create another branch. So I'll ask you all, what do you think is going to happen? Where do you think, if I go to create and I type git branch, branch 2, where do you think it's going to be created at? Like which commit?
Commit 3.
Commit 3, exactly. So let's create another branch. And exactly, git branch, branch 2 is the command we use to create a branch. And notice I'm doing this in 2 steps. You can use the git checkout -b and then branch 2, and then that will do what we're about to do in 1 step, which when you type git checkout branch 2, it'll move our head pointer. And so this is what the checkout command actually does. It moves the pointer for you. And this is represented by now we are on the second branch. We are no longer on branch 1. And so when we make changes and we add commits, they happen on this branch. So let's make some commits. Something to note, the way I have the commits represented here is if the commit's kind of like a gray, that's a little bit hard to read, it's because the commit hasn't finished executing yet. So we're about to type git add some file.txt and git commit -m with the message commit for. Just a quick basic thing from the previous workshop. So when we make this commit, 2 things happen. The first thing is git will create commit 4, right? This represents the set of changes represented by what we did. And git will do this for us. It will move the branch pointer along with the head pointer over to now point to commit 4. And so something to point out is we can only do things that we are on like the head pointer of, like where we are. Like I can't move branch 1 or do anything to branch 1 when I'm not on branch 1. So hopefully you can kind of see why. And so let's go back to branch 1 and see if we can do something there. Because let's say that we have these 2 commit histories, right? Branch 1 consists of the chain commits 1, 2, and 3, and branch 2 consists of the changes 1, 2, 3, and 4. We say that branch 1 and branch 2 share the history of commits 1, 2, and 3. But commit 4 is only on branch 2. Now, let's say we were on branch 1 and we're like, hey, I want those changes. I want to be also up to date with what branch 2 is doing. So what we do is we first need to move to branch 1, right? Because we can't make changes to something if we're not on it. So let's go back and check out branch 1. Our head pointer will move to now point to branch 1 because we're on branch 1. And when we type git merge branch 2, this is the command we use. So git merge is just what the command is. And it's a little confusing. I always forget it. We are always merge into whatever branch we are currently checked out on. Some Git terminals will be a little helpful and they'll tell you like the name of the branch you're currently on in your prompt, like right above where you type the command. And so that can kind of help. But just know that you're merging branch 2, the name we specify, into the current branch. So when we type branch 2, that will apply, I would say before, which is we would apply the changes, we're actually just moving the branch pointer forward because now we have this concept of a branch pointer, which is just a branch. Any questions so far? Cool. All right. So this kind of brings up a worrying set of implications here, right? How do we keep branches in sync? This seems like a bit of a scary problem. And if you've ever worked with Git and tried to do merge branching since the last workshop, you'll discover there are a lot of things that can go wrong. So, but before we get into those cases, let's just talk about the main 2 steps you do. The way you merge a branch is you first check out the branch that's out of date using git checkout, branch 1, and then you merge the new branch into the current branch, which is what we just covered. Sorry, it was out of order. There we go. So now we have 3 cases we need to consider. 3 main things that can go wrong when we merge branches, or that can happen. The first is the situation of we just made a change on a branch and nothing has happened to the previous branch. Like branch 1, for example, didn't have any other changes since we made that change. And we just want to update branch 1 to have the new changes. And that's what we just covered. I didn't put this in here, but the Git calls this a fast forward. So if you ever do like git merge, it'll just say fast forward, and that's what this is called. The second case is we make new changes, like we do some commits on branch 2, and then we go back to branch 1 and we make some more commits. We make different commits. And so we have this interesting issue of, okay, we've made 2 sets of changes here. What happens? How does Git figure out which changes to keep, which changes to remove? And that's the second case, which we're about to go into. But the most concerning one is what happens when we have conflicting changes, right? Like let's say branch 2 modifies like file a.text on line 7, and branch 1 modifies file a.text on line 7, and Git's just like, you told me you want two different changes, I don't know which one to do. Something to note is you can modify. The whole point of Git is you can modify to the same file at different spots. It's just when you modify like the same exact location is when it becomes a problem. And we'll go into that case in more detail. But for now, let's look at the second case, which is having different history. So let's say we have file1.text and file2.text. File1.text and file2.text. And let's say we go over on branch 1 and we want to, on branch 1, we want to change file 1 just in some way. It doesn't really matter. And we want to create file 3. Pretty easy. And then over on branch 2, we want to change file2.text in some way. We can see that these changes don't interfere with each other, right? We're not changing the same file at the same location, and adding something can just be undone. So that's compatible. So let's go ahead and make these changes and see what these look like on the graph. So let's start off with some history here. We have commit 1 and we have commit 2. Branch 1 and 2 are on commit 2, and we're currently checked out on branch 1. Now when we change file1.text, Git will create the commit 3. Well, actually, we create the commit 3 by typing git commit, and then Git will move the branch pointer for us. From now on, I'm going to show these in the same step, by the way, because hopefully the concept is clear there. And now that we've changed file 1, we're going to do the second change, which is creating file 3. And now we want to make the changes on branch 2. So we'll check out branch 2, moving our head pointer over. And now we have an interesting situation, because where does this new commit go? I said before that they're a linear sequence of events, right? And so like it might make sense that we can add commit 5 at the end of commit 4, but could we also add it at the end of commit 2? Like, what do you guys think the right solution is here? It's two options. You can always guess. Come on, Braden. I know you want to.
Pick it on the end of commit 2.
End of commit 2. Why do you say that?
Because it's a binary tree. Or it's a tree. It's not binary.
Spoiler alert.
I'm looking at it and I'm like, because they're pointing backwards, right? You can like just say like, yo, there's a new thing that's pointing at this commit, and I'm working on it.
Yes. So I think you're like almost saying the words that actually say the reason. So I'm just going to kind of work off of that and say yes. So commit 5 does point to commit 2, and you update the branch. And the reason for this, right, is because we still want to represent the shared history. If you're familiar with trees or graphs, technically it's a graph, directed acyclic graph, but we don't have to worry about that. So if you look at branch 1, the history of branch 1 is you start there at the branch 1 label and you go backwards. So branch 1 consists of the changes of commit 4, 3, 2, and 1. Branch 2 consists of the changes of commit 5, 2, and 1. Notice how efficient this is. We don't have to duplicate the history. Commit 2 and commit 1 only exist one time, if we kind of follow this idea of having the kind of split at this point. And you'll also notice this is why we have the arrows pointing backwards, so we can actually go back and see the shared history. Now, you might ask, well, if we're pointing backwards, how do we go forwards when we create commits and move the pointers? That, I don't know. It's just an abstraction detail as part of Git. So now let's try doing the scary part, which is merging branch 2's alternate changes into branch 1. So let's say we're on branch 1, we changed file 1, we changed file 3, and we're like, actually, I want the changes from changing file 2. That sounds awesome. So what we do is we first need to check out branch 1, right? So we'll git check out branch 1, and that will move our head pointer up. And now when we type git merge branch 2, something very interesting happens. Git will actually create a commit for us. Pretty snazzy. And this commit's also a bit weird too, because it points to two things. It points to commit 4 and to commit 5. Now, this is called merge commit. It's because it's auto-generated by Git. If you use like a GUI client, it'll actually like prompt you when this happens. It won't just do it for you, but Git will sometimes do it for you. So the kind of special part about this merge commit is it represents the changes that have happened as part of the merge. And so Git creates the commit for us. We move the branch, or Git moves the branch over. And now if you notice, from branch 1, we can go back to commit 5 and we can go back to commits 4 and 3. So we don't really need branch 2 anymore because we can just go back to it from branch 1. So as we don't need it, we have another command we can use. Git branch has a flag called -d for delete. And if we just type git branch -d branch 2, that will delete the pointer of branch 2. So something to point out here is, again, the efficiency here. So notice how commit 6 or commit 5 is not duplicated. We don't have to, commit 6 points to the original instance of commit 5, the changes that were made and recorded once. We don't have to re-record the changes and be like, okay, if you're going back into branch 2's history, these are the changes. And then if you go back into branch 1's history, these are the changes. The kind of magic about Git is that we can preserve these states as we go along forward. Sometimes commits are called snapshots. So that covers our second case. Are there any questions about this case, by the way? Or things about merge commits?
Question.
Yes, Brendan.
So, like at commit 6 is just the aggregate of all of the changes and the node for it.
Yeah, so... Oh, sorry?
Sorry, continue.
So it depends. So sometimes commit 6. So right now, as far as I remember, Git 6, if there are no conflicts, the commit 6 will just be empty. And it will actually just represent the changes like kind of internally. But once we talk about conflicts, which is like the next example, we'll see what we actually put into commit 6. Because Git has a pointer, if you like look at like the Git log or you look at like a diagram, like one of the applications that can actually draw this graph for you, it will, or not to draw the graph, but it can show you the list of commits. It'll actually just show commit 5 as if it's a linear sequence. This is kind of more about how Git works sort of internally.
Okay.
There are applications that can draw this for you and they'll show it like this. So that's why I'm mentioning it. But yeah, that's a good question. Yeah, what is in the merge commit? We'll see that soon. Any other questions? All right. So let's get into the final scary case, which is making conflicting changes. This is the absolute nightmare of Git. This is the thing everyone hates, and this is the thing that we are going to do well. So let's say we have file1.txt, and we have 3 branches. We have our main branch, which is like the original branch. We have branch 2, and we have branch 3. Now, when we create these branches off of main, file1.txt, all it has in it is just my favorite color is yellow. And let's say that we want file on branch 2, we're like, hey, I want my favorite color to be red. So we created kind of a new group here. What we just did is we created branch 2 and branch 3 off of main. And as you can see, the files are the same. And note that our head pointer is on the main branch up here. So this is representing where we're currently checked out. This is going to be a little bit conceptual, but I hope you can follow along. So now when we create a branch, the best way I can explain this is our branch remembers what the last state was of the branch that we left, right? So think of it like you're leaving your house for like a vacation. You remember what your house state was. If you come back and all your furniture is like different and your walls are suddenly green, you're like, okay, what happened here? I didn't expect this. Like you expect things to be the way they were when you left. So same way, Git branches expect a certain state when they leave. So, and we'll kind of see the diagram for this, I think, at some point. And so when we actually go in here and we actually want to make changes on branch 2. And so, we make a commit that changes my favorite color is yellow to my favorite color is red. And, that's okay. And then now what we do is we go back into the main branch. Because remember, the branch, we want to check out the branch that we want to make changes in. So if we want to merge into the main branch, we need to be in the main branch to actually do that. So what we do is, first Git will do a small check and say, okay, when we go to the main branch and we try to merge, we expect a certain state to be here, right? So we're expecting yellow to be in the main branch. And it's going to do that check and be like, okay, is this okay to do? There's a small error in the slide here. Sorry, this should say yellow here. I'm actually going to correct that very quickly. Sorry for that. Wrong button. Sorry about that. So yes. So when we go into the main branch and we attempt to call merge, Git's going to first check to see is what we expected the same. In this case, it is, right? Because yellow is still in the main branch and we're good. And so when we do the merge, we update the main branch because we just merged the changes from branch 2 into the main branch. And we update our expectation because we checked that the expectation is what we thought it was, and we update it because both the new changes and the old changes are what we want. So now when we go into branch 3, who has not heard of this change, we have not told branch 3 about what's going on. Branch 3 is still expecting yellow when it goes to main. And so branch 3 is doing its own thing, and doing its own thing is changing the favorite color to purple. And so when we go back into the main branch and try to merge branch 3 in, Git's going to spit us a very ugly error and say, hey, merge conflict. You tried to change something that the new branch wasn't aware of, and you made the changes without telling the new branch. And so this is the expectation idea. Branch 3 is still expecting the color to be yellow, and the main branch has since done something else that we haven't notified about. Now, something to note, this only occurs when you modify the exact same position in a file. This doesn't occur when you make different changes because otherwise we would have git commits or merge conflicts literally all over the place. The reason why we have merge conflicts is because Git doesn't know what to do. It doesn't know who's right. It doesn't know if branch 2 is correct because it did it first, or if branch 3 really should have had the authority to make that change. So when this happens, we kind of ask ourselves, well, how do we fix this? So remember that we're in the main branch because we're making changes in the main branch. And if you go look in file1.txt in this case, Git's going to do something weird to it. It's going to modify it. It's going to give us all this stuff down here. What all this stuff is we kind of have two sections. Head, remember, is where we currently are. And as you can see from the diagram all the way on the top left, we're on the main branch. So this represents what's on the main branch currently. And then on the bottom, underneath these equal signs, it says basically the changes that were on branch 3. And so the way we fix this is a little bit manual, unfortunately. We literally just edit, just in our code editor, we just select it and we change this block of code to be what we want because Git doesn't know what to do with it. Now, if you use VS Code or some other kind of IDE, it will offer auto buttons for doing this kind of stuff in line, and it's very, very nice. But just know that if you have an editor that doesn't, or if you just forget, it's just about editing this thing manually. So you want to change the file to be what you want it to look like. In this case, because we're trying to merge branch 3 into main, I personally want the favorite color to be purple. And so I'm going to modify it and be like, okay, my favorite color is purple. This is what I'm expecting. I don't know what you're talking about with all that red business, but I want it to be purple. So when we actually, the way we do this is we just create a commit. How else do we record any change? So I'll just commit it as fixed merge conflict. It'll update the main branch because we just made the commit. The merge will complete. And something interesting will happen is notice how branch 3's expectation is now updated because main branch and branch 3 have agreed, okay, the change is now purple. We now expect purple to be there. So is there another problem we can see here as to what might be a problem here as a result of branch 3 now expecting purple? Or just the main branch changing to purple?
Branch 2 is expecting red.
Exactly. Branch 2 is expecting red. Branch 2 has not been updated about what's going on. And so the way we fix this is called, we do something called back merging quite a bit. And so we'll talk about this a little bit later in the presentation, but just kind of be aware this doesn't have to be an endless cycle. There are ways around this. And we'll talk about that a little bit later because it's not quite relevant to this specific case. So this is for keeping branches in sync, and that was our third and final case of merge conflicts. Now let's dig into merge conflicts a little bit more because I'm aware that was a little bit quick of an explanation. So merge conflicts occur when we merge branches with the same changes in the same place. And something to ask is where else do we do merges, right? We don't just merge between local branches. There's a little hint there. What's another place when Git does a merge? What other commands does Git do a merge on our behalf of? Starts with a P. Well, there's a push and a pull. And so remember that one of the things that Git does when you pull from a server is it will download the changes and it will merge them locally. And so that's another place where we could run into changes and run into problems. So a scenario where this would happen actually makes a little bit more sense to like kind of explain, right? Because let's say that you're working on your computer locally and you're editing some file and you're just making commits all day, and someone has just been constantly making commits on the server, just overwriting like every single file and doing all sorts of crazy stuff, and you've never pulled from the server, and so and you've never told the server of all your changes that you made, and so when you try to pull from the server, it gets like, okay, man, someone else made a bunch of changes in here, and now you're telling me to make a bunch of changes, and I don't know what to do right now. I don't know who's correct. And so you can't just kind of look at what the most recent changes are and just accept the most recent change, because those aren't always correct. From personal experience, I can tell you that in all the merge conflicts I've solved, it's not always been like accept the latest one. You really do have to like read it and be like, okay, what's the right thing to do here? When I personally see merge conflicts, it's usually like some weird configuration thing that's come up. Braden kind of like your project with Brickhack stuff. So that just kind of happens sometimes. So back to pulling. So we do have another way of doing this. So instead of, well, not, I shouldn't say another way, but we do have a way to prevent just having an immediate merge conflict, just out of the blue, which is we do something called fetching before pulling. So pulling downloads all changes from the server and in one step immediately merges them locally into the current branch. But fetching, on the other hand, just downloads the changes from the server. And so we can use a command later called git diff, which we'll talk about in a little bit, to actually compare the changes and see beforehand what's about to happen. So one example might be like let's say you change some file and you're like, I don't really know if I want to make these changes, like you add some comments or whatever. You fetch from the server and you see that someone else added a bunch of code in there. And you're like, okay, I actually want that code to be here. My comments don't really matter anymore. So at that point, you would just go in, delete your comments, create a new commit saying, hey, I deleted the comments. And then you could just do a git pull, because now there's going to be no merge conflict because you saw that there was going to be a conflict and you got rid of your own changes that got in the way of that. So that's like one scenario. Now, something to note is this can be a bit frustrating on the command line, and this is why I personally use a Git, like a GUI client, like a graphical client, is when you pull, you need to have a clean working directory. Now, I don't know if you absolutely need it for sure, but I always have issues when that happens. So it's also just generally good practice. So the way we can have a clean working directory every time without having to like immediately commit whatever we're doing is using stashing, which we'll also talk about soon. Now, some more tips for avoiding merge conflicts. Make sure to pull often, because this is how we actually stay up to date. We make sure to pull and push quite frequently, because the chances of you making 50 commits and the chances of someone else making 50 commits are a lot less if you guys are pushing and pulling frequently. And before making any changes on your branch, make sure to pull, because let's say someone uploads a change and you didn't hear about that change and you just start working on your code. If you had just pulled before you started, you wouldn't have had a merge conflict. So that's one common case. And then also do something called back merging. So the reason why back merging is a thing, and what it is it's just merging backwards. So we have, let's say we create branch one off of main, and we're working on branch one and doing stuff. The goal is to merge branch one back into main, right? Or it can be the goal. And so that's why it's called back merging, is because we're actually updating branch one with the contents of main because we've had some changes occur. This is part of something we referred to last time as Git flow. I think I briefly mentioned it. And we'll talk about it a little bit more. Keep your eye on the CodeRIT Discord. We may do an additional workshop diving into like all the details about collaborating on Git and GitHub, which is a little bit different from all the theory kind of stuff we're talking and practical things we're talking about today. But yes, just kind of be aware that back merging is a thing. Google around and there's some great resources that talk about this in detail. Something to note is when I took Intro to Software Engineering here, I remember this very vividly, is one of the questions on the exam was, how do you avoid merge conflicts? And one of the answers was something along the lines of like writing less code. And that kind of really infuriated me, because not necessarily. What I personally recommend is just pulling and pushing more often and being clear with the other people on your team as to what code files you're modifying. So that concludes branches. Does anyone have any like questions about branches, merge conflicts, merging, any of that kind of stuff? All right. So let's move on to kind of a bunch of miscellaneous things about Git that we just haven't really had a space to talk about yet. And one of them is undoing mistakes. And we'll cover this very, very briefly. We're not going into too much super detail here. So what happens when we screw up? Like when we write something wrong, or like we made a commit that was bad, or we want to undo a commit. Now, I want to make a very, very, very strong point here. You cannot edit changes once you push them to GitHub or some server. And I'll make this point even stronger. You cannot edit push changes safely. Because what happens is, if you can think about it, right? You have your local Git repository, you're working on stuff, and you push and Git freaks out, and you're like, you know what? My changes are correct. And so, like, let's say you just deleted all the commits in the repository or something like that. And which you can do. And you push them to the server, and someone else has no idea that you've done this, and they just try to pull Git. The entire repository is broken. I thankfully have not had to encounter that, but the situations what happen when someone force pushes, that's the command you would use when you force push something that goes wrong and like changes in history. Not pretty at all. And so something I will caution is if you Google around on Git, like a Stack Overflow and other things like that, you may come across people saying to use push force. Very, very, very rarely needed. Only use it if you really know what you're doing. It's pretty dangerous. Yes, I really just did spend 2 minutes talking about a command not to use. So just want to be aware of that. And so you might say, well, what's the solution to this? Just be careful when you push. So like if let's say you're working for like 2 hours, what I'd recommend is like if you're working for 2 hours, like make commits locally for the 2 hours, and right when you're about to be finished, kind of like read over your commit messages, check to see that there's no like typos or anything, and then push everything all up at once. So one of the problems you can run into, or mistakes we can make, is we have a typo in a commit. I do this all the time. And there's a very simple way to do this. If it's the last commit that you screwed up, just do git commit -- amend, excuse me, and then -m, which is the new message we want to have. Now, the way this works is it doesn't actually, I have to say this, it doesn't technically edit the message of the previous commit. What it does is it overwrites the previous commit with a new message. So we're like reapplying the changes with a new message on top of it. You can read into I have some resources linked to the end of this that digs into how this actually works. We didn't have time to talk about rebasing today, but that's one of the key strategies it uses. And also note that amend is with 2 dashes. There's no official slide for this, but there's 2 types of, we call these flags, and there's 2 types of flags. The first type of flag is the 1 dash, and that's just short, and the second is long. And so amend, because it's like a full word, has 2 dashes. It's like a Unix thing. If you just Google Unix flags, you can find whole articles describing like why it's like this. But that's why there's like 2 dashes in that one. Now, undoing a commit, we have also a very simple way to do this, which is git revert head. And what this does is there's a lot of ways. There's so many ways to undo a commit. There's like really dangerous ways, there's very easy ways. But revert head, what this does is it's a little clever. It actually just creates a new commit with all the opposite changes, because Git keeps track of what you added and removed, and so internally it just flips what it thinks those are, and it just reverses all the changes you just made. And so it's pretty clever. And again, this has like a ton of options and a ton of other like edge cases and things like that. So please do some more reading if you're interested on how to undo things. So that covers undoing mistakes. Again, there's a lot more to this, but we don't have time to get into it today. Next, we'll talk about something called git ignore. So if you've ever worked on a code repository with other people, especially on like Mac and Windows, or if you've just tried using Git already and you notice there's a bunch of garbage in there. There's a lot of garbage. There's like .class files from Java. Like we don't care about those. Like those are generated by the compiler. We don't care about .o files. The .idea folder from IntelliJ is just a bunch of random stuff. I don't know what's even in DS Store. And it's like all this other stuff. And so Git actually has a mechanism to just ignore these files. To just be like, hey, I don't care. Like, please don't keep track of what these files are. They don't matter. We need them. We need them locally. We need them to run our project, but don't keep track of them. And the way we do that is we have a file. The file is .gitignore. Now, if you go into like File Explorer on Windows or Finder on Mac, and you open like a folder that's got a Git repository, that is a Git repository, you won't see it, and that's because the dot there means it's a hidden file. If you Google around, there's ways to like enable this to work. But typically what you can do instead is there's like, if you want to see the file, there's a flag usually in your code editor or for the ls command or the dir command on Mac and Windows respectively for seeing hidden files. But mainly you just kind of edit it and leave it there. And what this file does is it defines a list of patterns to ignore. What do I mean by patterns? So these are kind of three situations that we have. The first thing is we can just, in this file, we can just name specific files that we want to ignore. And so in this case, it would just ignore every single file called .dsstore. And Git will just not keep track of it. If we put and like a /* at the end, that's saying whenever you see a folder called .idea, ignore everything inside of it and the folder itself. And so this is useful for things like the .idea folder. If you're in Swift, there's like an Xcode proj folder you might not want to keep, things like that. And the final pattern is just using * dot and then like some extension. And so if you're working in Java, for example, it may be helpful to do add the class ignore like *.class because that will just ignore all class files. It's very helpful. And something I didn't put in here is that let's say you like already committed a bunch of class files and a bunch of other things like that, and you add your git ignore. Git will not suddenly like remember like, oh, you want to ignore this. It's kind of one of the unfortunate sides of Git. I was just Googling for, you have to do something called untracking or excluding, and you have to kind of tell Git like, hey, I know I just gave you a list of all the files I want to ignore. You forgot to ignore these ones. Please go back and like ignore these again. Because you already told Git you want to keep track of them. So that's something to be aware of if you run into issues there. And you might say, well, I don't want to type this git ignore file every time and I can't remember all the things. Well, gitignore.io is your new favorite website, because what it does is you literally type in what language you're using and what operating system you're on, and it will generate a huge git ignore for you and just put everything you couldn't even think of. Like Java, I didn't even know that there were .log files in Java, but apparently there are. So things like that. It's very, very useful. And one thing to remember too is .gitignore is something you commit. This is something that is tracked and everyone shares. So make sure to commit this file. You don't just kind of keep it locally. Git needs the file, or not needs the file, but in order to ignore things, you need the file in your repository. Cool. So now let's dig into just some random assortment of useful Git commands, now that we talked about git ignore. So this is one of my favorite commits in Git, and it's so much fun, and it's actually very helpful. Because I don't know about you guys, but whenever I write, I'll be working on a project sometimes, and I've seen code like this. I don't know about you. My first question is, who wrote line 5? This is interesting to say the least, because if true is just going to always be true. And so Git has a command called blame, a bit rudely named. What you do is you pass in a line range. So you do -L space and then like 2 numbers. And this will do like a range of lines and the file name. And what this will do is this will return basically a description of who wrote those lines. Like it will literally give you their first name, last name, and email that they have with Git. Like it's absolutely hilarious. I've done this before where I've literally worked on a project and I like came across some like awful code and I was like, who wrote this? I gotta see what's going on here. And it was me 2 weeks ago. So that will happen at some point. So just be aware. But I personally don't like using this on the command line because it gets very, very messy and I don't like doing the -L thing. Just use GitHub. Like this will be answer for a lot of things today. But if you open the file in GitHub, it actually has a blame button on the file. And when you click it, it has 2 unique things. So the first thing is it shows you the exact commit message about when the file was changed, like as a part of what commit was this line edited. So we can see here, line 24, or let's say line 23 was edited as part of the copy majority of core logic from Brickhack repo. And it was edited by this guy, Stuart. And so I can then click on his profile, go to his GitHub profile, see all the other projects he's worked on, that kind of stuff. And it also tells us how long ago this was done. So this one's like 4 years ago. But I actually do use this feature basically like once a week. If you click this little button here right next to the line of the file, it will let you see what let's read it, see what the file looks like when the change happened. So it'll basically kind of go all the way back in history to when that change was made and show you changes from that point and previous. this is really, really, really useful. And one example is like, let's say that you have, like, you find some really weird piece of code that doesn't seem to be used, and but you can't definitively say it's used or not. What you can do is you can go on GitHub, click this little button, and see maybe there was like a commit that added some other functionality that's been removed since now. And you could be like, oh, well, since that code was written for some other feature, we no longer have that other feature. I can safely remove this code. That's like actually a fairly real world scenario that you would want to use Git blame. You could also use it to make fun of people, make fun of yourself, but let's try to be a little nice about things. I also know it's literally called blame. I think they've been talking about maybe changing the name of it. I don't know. The next one is git diff, and we briefly mentioned this when we talked about fetching and pulling. But one scenario that first came to mind for me was when I do git status, I completely forget what I've done. I have no idea what changes I made in here. And so let's say we type git status, and let's say I'm like, I want to see what I did in this manage.sas file. So we type, git diff and then the full path of the file, and we get a mess. We get an absolute mess of things. And so at this point, I would recommend to look into your command line prompt or your terminal and find one that gives you some pretty colors. Because when my terminal generates, it looks like this. It highlights all the lines I've added in green and all the lines I've removed in red, which is hilarious because I'm colorblind. But it shows lines I haven't changed in gray, and it gets this little double at thing in blue, which just kind of shows what line numbers have exactly changed. And so just kind of look through this really quickly to explain some things. Git diff, you type git space diff space, and then the path of the file relative to where you are. And it'll spit out some information, and it'll tell you what commit hash is. So remember, this is a little bit back, but like in the end of the first presentation, I showed that there's this unique hash that's part of every commit. That's actually how Git refers to everything. And so it just snips off the first 7 of that, like that SHA-1 hash, and that's how it refers to the commit. So that's what that is. All the lines below this dash 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 are all the lines you've removed. We haven't removed any lines, or I haven't removed any lines, so there's nothing there. And then shows the lines I've added. Again, this can get a little messy in the terminal, and it's really hard to scroll, and the terminal is really slow. So I also just normally do these in GitHub. So when you go to GitHub, click on a commit, it will just show you the whole history, or the whole diff, I should say. It also lets you do like split views or like unified views. It's very, very cool. Now, you can also not just diff files that are in your working directory, you can also diff across branches. And again, I would not even recommend trying this on the terminal. Just do it on GitHub. It's so much easier. I should also mention there are some weird things that happen with git diff. Like it compares like your staging area, but not your working area. Again, look through the documentation, which I'll show at the very end of this, that for all the details on how to do that. Git stash is incredibly useful. I use this every single day. It basically creates little snapshots of your working directory. It's like, okay, I was working, it's like, if we go back to the chef example, like if we're trying to cook a meal or whatever, like we're halfway through making like some sort of like chicken parmesan, and we're like, oh, I have to like go. And so what you do is it's like packaging it and putting it in the fridge to come back and make later. So that's all git stash is. And we create a stash with a name by doing git stash save, and then in quotes, we just put the name of the stash. If you just type git stash save, it'll just, or just git stash, I'm pretty sure. No, I think it has to be git stash save. No.
Just git stash will work.
Cool. Yeah, so if you just type, thank you. If you just type git stash, it will just save the stash like by some number indexed, which we'll soon see in a second. But I personally like to name all my stashes. And the reason is because I usually have about 10 stashes at a time. And the whole point of a stash is to come back to something. And I'd much rather just read what the stash name is. It's just easier. So let's say we type git stash save. So we save the stash, which are all the changes in our working tree, or in our working directory. We can see what stashes we have by doing git stash list. And that gives us a little bit something weird here. And what this is basically just stash at, and then in curly braces 0. That's just a reference to the current stash. And so if we have more than one, it's going to be 1, 2, 3, 4, 5, and so on. And it tells you what branch the stash was on, and it says trying to fix the login bug. You might try to be really clever here, and instead of merging, what you could do is you could create a stash and then check out the other branch and then apply the stash, but I would not recommend doing that. But if you do want to get in, when you're actually finished and you want to actually apply a stash back into your directory from storage, I guess, git stash pop, and then you put the little reference here. I actually thought that you could do this based on the stash name, but it's just easier to do it based on the stash reference. And then finally, if you want to just remove everything, all of your stashed files, you can do git stash clear. So something I want to briefly mention is my Git client I use called Tower, free for students, has what it can do is it can like auto stash things for you, and all the Git clients will offer some very, very nice, pretty interface for managing stashes. So just a heads up there. All right. Now, if you're aware of other Git commits that exist, we just haven't had time to go into them. I really do need to breeze through this best practice section here. So when we talk about all this stuff in Git, like how do you like write commits, how to write commit messages, how much do I put inside of a commit, when do I merge branches, like how often do I do these things? Generally, if you're working for a company, ask what their style is. If you're coming into a co-op or an internship, they will tell you. But in case they don't, you should definitely ask. And if they don't have one, be very, very suspicious. Usually not a good sign if they don't have a standard for how to contribute to things. But through this section, I'll just kind of explain what I've personally seen like throughout using Git. They're just kind of general guidelines. And this applies to commit names, branch names, how often to commit, that kind of thing. And if you're working alone, you can of course do what you want, but generally it's a good idea to stick to some kind of standard just for your own like sanity. So for commits, I recommend putting one discrete change per commit. So if you're like refactoring 7 methods, maybe don't put all 7 method refactors in one commit. Maybe like per method, you can put them in one commit. Or actually a better example would be like if you're like, let's say you're adding some login functionality and some logout functionality, maybe split those into 2 separate commits instead of just doing one huge commit. As a general rule, I'd suggest doing 1 to 100 lines of code per commit. Because generally when you have commits over that, it gets a little bit messy. There are exceptions, like for example, let's say you're renaming a variable and you have 300 occurrences of the variable. It's like, okay, fine, you've made more like 300 changes, that's okay. The main thing we're trying to avoid is if you go back in your Git history or you're reading through the commits and you just have a commit message that just says like bruh or something and you click on it and there's like 9,000 changes. I've seen this happen, like 9,000 changes. It's like, this isn't helpful. The whole point of Git is to be able to look back through the history and see what's going on. And so kind of do it for your future self. Make things that are concise. For commit messages, speaking of conciseness, as before, messages should be less than or equal to 50 characters long. Again, if you need a longer one, just type git commit, no arguments, and it'll tell you how to do that. When pushing to GitHub, feel free to use emoji. If you click on the link in the presentation slides, which we will provide after this, or in the video description if you're watching on YouTube, it has a bunch of emoji you can use. My favorite one is Ship It. It's like a little squirrel with sunglasses. It's amazing. Or chipmunk, sorry. For the message descriptions themselves, there's a lot of ways to do this. I personally use past tense, so I'll be like fixed change startup crash, login now works, refactored method X. But I found a couple blogs that recommended using imperative case, like fix this, login now works, refactor this. It's just kind of just keep it consistent. Branch naming, there's a lot of ways to do this. You may first think like if you're kind of just starting out, you're working on a group project. I did this for years. You might think it's a great idea to have branch names just be your real names, like whoever's working on the project. But if you, let's say, like come back to the project after like a vacation and you have no idea what's on the Dave branch, it's like you might go ask Dave, like, hey Dave, what's on your branch? Like what changes are represented by your branch? Dave might not know. And then now you're in trouble. So this is kind of a not super great recommended way, but it's good for like if you just need to blast out a project in a week, it works. Instead, what I personally recommend, and I see used a lot, is a feature naming your branches based on what they're actually doing. Now, if you use GitHub issues, which we may talk about in like the collab workshop if we do one, if you use GitHub issues, generally what you can do is GitHub will add a little number associated with each issue. There we go. And you could put that in the actual branch name. And so alternatively, you can just name it with text. So like we have one branch called add comments. All the changes on this branch represent the feature of adding comments to the website. Optimize is maybe not a great branch name because it doesn't tell me what I'm optimizing or what's going on. Fix login, it's a bug fix, fixes the login. Note that one cool thing about branches is like we can fix login and then merge that into like a develop branch here, for example, which we'll get to in a second. And then we can just like leave the branch there And then when we ever have a login issue again, we can just merge develop back. We can back merge develop into login and then like reuse that branch, so we don't have to keep recreating it. Let's change the captions by the way. There we go. All good. So yeah. Now you may ask, why do we have a develop branch? Why don't we just merge directly into main? This is kind of another best practice, and this is followed. I've only seen like one repository not do this. Main branch is the source of truth. Someone should be able to download or clone the main repository, the repository, and be on the main branch, and everything should work. The situation for this is like, let's say that we're working on fixing login, and we fix it, and we merge it into develop, and develop works. And then let's say we're adding the comment feature. We add the comment feature, works great. Merge it into develop, merged, no conflicts. Something's still broken. And this isn't ideal. So you can kind of think of it like main being like production. For CodeRIT, like in a couple of our repositories, we're kind of renaming our main branch to production because it's just a little bit more clear about what's going on. You'll also typically see a staging branch in the middle of this. Staging is just like another intermediate step. It's like right before we have a release, let's save it in staging. And this also prevents us, by the way, from having, like, let's say some catastrophic merge goes wrong, like something goes horribly wrong in develop, we can just delete develop and then clone from master, branch off from master again. If that happens in master, I wish you luck. So I want to leave with some parting resources here and a brief topic about forking. So I found this website a couple days ago called Dang It Git. It literally is just a bunch of snippets about when you do things wrong, what to do. Like what happens when I delete my branch and I want it back again on GitHub? What happens when I commit something I didn't want to commit? Like all those sorts of basics, but also some more advanced weird edge cases that do happen. Another one is, this is the reference documentation I was talking about. This is like the man page if you're familiar with Unix. It has every possible flag on every possible command in Git. So if you ever forget, like I want to check out and create a branch and I forget what that's called, you can go in here, click on checkout, and read to your heart's content. Another one is there's this cheat sheets. There's a couple cheat sheets from Git Tower. They make a Git client, but they also provide these nice little cheat sheets for the command line. These cover everything you need. I have a couple talks to recommend too. This one's by Jessica Karas. This is oh my god, it's almost a decade old. But this is kind of intended for people who used Subversion, which is like a previous one. But it goes into amazing detail about like how Git actually does everything. So it kind of combines our more theoretical approach with something a bit more like, okay, how does Git actually work internally? It's still very beginner focused, and she kind of emphasizes a lot of the vocabulary stuff, Git, all the jargon. Now, if you want to dig into the details, this guy is like a little crazy. He actually literally starts creating the Git folder himself from scratch and like works his way up to like a Git repository. It is almost literally Git from the bits up. It is fascinating. It's entirely live demo too. It's absolutely great. Highly suggest watching that one, but maybe after this one. And one final kind of site to mention is just GitHub pages. GitHub has a great video explaining this, but in essence, it lets you host a website for free. If you have a GitHub repository or a Git repository and push it onto GitHub, and it's a website with an index.html file, Git will give you a free domain, like your username.github.io, and it will just render whatever HTML file is in there as your website. And they have like themes and stuff you can choose from. You can have a blog. Highly suggested if you're like a web and mobile computing major and you want to have like a portfolio, this is the place to put it. Because then recruiters can also see like the source code for it, which is cool. And as a quick tip, one thing I did personally for when I used to have one, as I like redesigned my portfolio, I would just keep creating branches for it. And so I can like kind of go back in time and like see my old things. So that was kind of nice. All right. So that concludes our overall presentation, but almost. There's one brief thing I want to mention before we kind of end the recording here, which is about forking. So I just took this screenshot from GitHub because I think they did such a good job explaining it. Forking is something you do in GitHub. It's not a part of Git. Basically, it's, let's say you find someone's repository that you really like and you want to change it for your own. Instead of downloading it to your computer and making all the changes locally, forking creates a duplicate from their account onto your account of that repository. And it keeps a reference to it. So this is like how you actually contribute to things like open source. You fork the repository, you make changes, and you do some kind of pull request back in. But this is the mechanism we're going to use for the workshop today. So we're going to post a link in the Discord in the Git Workshop channel in a moment to the repository. And if you're logged into your GitHub account, you'll see a fork button on the top right, and that was what you'll use to actually create your own copy of it to actually make changes. And this lets you practice polling and cloning too, which is great.
And
So
real quickly, I just realized, Peter, one of the things we forgot for best practices, README files. So
yes,
yeah, do you want to talk about that? Yeah.
yeah. So a README file is basically just a like general description about what the repository is. And so what it is it basically it's a markdown file. So you can do it as a text file, but markdown is just this really cool thing. It's made by John Gruber, which I feel like his name doesn't get around that much anymore. He's like a journalist now. He basically markdown is just a really simplified syntax for doing HTML. It's not an accurate explanation, but it's an explanation. And so a README file is just a way to describe what all your code does. So I'll give you an example. If we had to actually go here, I could have the captions running while I screen share. That is awesome. So I'm going to go to like GitHub. Let's use Mozilla Firefox iOS again, just because it's a big repo. So any repository I go to on GitHub, again, this is like a best practice. If I scroll down, it's going to show me this is the README. It will auto render the README right there, and it says like a title. It tells us like what version we're on. It gives us some links on the App Store. And then typically a good README will describe how to build the project, like how to actually install things. And it'll go into detail about like how to contribute, a bunch of guidelines. It's a very, very, very standard thing. Please write READMEs. I've had friends hired because they wrote READMEs on their GitHub repository, and the recruiter was like, wow, you actually wrote READMEs. That's awesome. I've never had that happen, unfortunately, but I do write READMEs on my repositories. And they don't have to be huge and glamorous, but they can be. You can also have like images and stuff like that too. Thanks for bringing that up. Yeah, good point. Any other questions anyone has, or before we get into the workshop? All right. I think that ends the presentation portion of this. Thank you all for coming, and we will be in the Discord channel, voice chat, and the text chat if you have any questions.